Hello and welcome. Good evening, everyone. My name is Gopal Krishna R, Associate Editor of OEM Update Magazine, and I welcome you all to the OEM Update Magazine's active session. India, shaping third largest automobile industry. I have my colleague, Ms. Rajeshwari Venkatasubramanian, editorial, OEM Update Magazine, to introduce the panelists and moderate the session. I welcome Ms. Rajeshwari to take over. Thank you.
Thank you, Mr. Gopal. Hello, everyone, and welcome to OEM Update Magazine's interactive session on India shaping third largest automobile industry. India is shaping to be the third largest automotive industry globally by 2030. It is the fifth largest market and aims to achieve 100% electrification by 2030. The World Economic Forum ranks India 30th on the Global Manufacturing Index, which assesses the manufacturing capabilities. Connectivity is still in the early stages of adoption in India. The demand for electric mobility will bring more innovations and different players like software and technology providers to enter the automobile industry. The PLI scheme would promote the domestic manufacture of electric and hydrogen fuel vehicles and boost local ACC battery storage products for the Indian EV industry. The government's ease of doing business and Make in India initiative are essential in elevating the country's position. Through the Automotive Mission Plan 2026, the National Electric Mobility Mission Plan and other initiatives, the government seeks to achieve two objectives: facilitates long-term growth in the industry and reduce emissions and oil dependence. On this note, today, we have come together to witness an engaging interactive session on India shaping third largest automobile industry. Ladies and gentlemen, it's an honor and a privilege to introduce you to today's distinguished speakers. Mr. Arindam Lahiri, the CEO of Automotive Skill Development Council, Mr. Rajesh Kumar Penchala, Vice President Atrio Automobile Private Limited, and Mr. Puneet Jain, the founder of Natural Batteries Technologies. I would invite all our guest speakers to join us for today's panel discussion on India shaping third largest automobile industry. I also invite Mr. Gopal Anand to join us for this session.
Mr. Arindam, you were talking about automotive components market, about India and the skill developments. And without skill development, there cannot be sustained growth. And as you all know, there is a massive shortage of semiconductors that has disrupted the production of Indian automobile industry. Mr. Arindam, the crisis will likely to continue this year and will impact automobile production in the country. What do you suggest as a way out from this crisis?
No, I think this specific problem of semiconductors is something which probably should have been estimated given the speed at which the various applications have started consuming semiconductors. And as you all know, that fab manufacturing facility is very capital intensive, as well as it has a long gestation period. So semiconductor chip manufacturing capacity enhancement happens in like a step function, what we say. It's not a gradual curve that you keep upgrading capacity across the globe. And we also have to remember that the basic chip that we put in the cars also compete along with that capacity in many other applications across our lives, and it's a common knowledge that automobiles ranks the third largest user of semiconductors today in the globe, the biggest being in the telecom, the handsets, and then you have the computers which consume a lot of these semiconductor chips. So I think this is a phenomena which was kind of, I would say, we kind of all missed the bus in terms of making the right prediction. Now, given the prediction is there, I think soon we'll face a situation where we'll have excess capacity in semiconductor chips, and hopefully I think people will stop discussing about chips again in the context of semiconductors. But more important, I think, is if I look at it from my perspective of skilling, the application areas where you could look at integrating electronics?
An automobile industry is facing right now?
Unfortunately, in the recent past, the chip shortages have disrupted the complete supply chain, and especially for automobile sector, it's a big blow. And you can see with the number of sales that have happened in the last couple of months, not just for electric vehicles, but even for automobiles, the regular ICE engine automobiles. By the way, just to make a note, India always had been having kind of semiconductor manufacturing companies in the ecosystem, but however, that has not taken up a shape to cater to the demand that we are looking at today. So, as Mr. Arindram mentioned, we definitely missed the bus where we could not capitalize on what we have built. So especially some of the cities have something called Fab City, where they're catered towards, those clusters, industrial clusters were developed to cater to the needs of these chip semiconductor manufacturing companies. But however, in the past, when there was not much of a demand, where companies could not really capitalize on. But now with this sudden onset of EV adoption, companies have totally missed the bus, and we had to extremely rely upon the some of the Chinese companies. And today, at least, we are happy to see some of the Indian conglomerates working on setting up the semiconductor chips manufacturing units, and someone like Tata is about to begin their chip manufacturing. So the localization of these chips also would help Indian industry to grow, and help us to curtail the imports of these key components from outside India. So that is one key aspect. And when it comes to handling of these shortages from eTrio standpoint, yes, that definitely impacted our supply chain too, and that has escalated our cost of purchase of most of the components that heavily depend upon these chips. And to mitigate the risk, as Mr. Arindam said, we hope to see not to see this kind of a chip shortages in the near future. But however, to mitigate the risks, we have identified alternative suppliers, not just based on one region but multiple regions. That's one way that we tried mitigating a risk. And the second aspect is validated from these players in parallel, so that you can depend upon one of these guys whenever there's a shortage from one industry area. So that's one second aspect. The third and the major important factor is exploring these chips within India itself, with a lot of small scale and large scale companies coming up into this chip manufacturing. We would love to see Indian startups getting into this chip manufacturing with lots of government support, and we can see PLIs and ACCs, of course ACCs for batteries, but again PLIs schemes would really enable companies to come out with manufacturing setups in India, not just to cater to Indian ecosystem, but outside India as well. So, however, we see a lot of momentum happening on that front to have in-house capabilities for India, right, and reduce the dependency on imports, be it chips or batteries or cells, or even powertrains. So going forward, we already have been in talks with multiple players, especially on the battery and cells within India itself, that reduces the cost as well as dependency on uncertainties in terms of supply chain. So good days are yet to come, especially with the localization of all these key components in India.
Thank you, Mr. Rajesh. Good days are yet to come. That's very optimistic view about it. Mr. Puneet, Mr. Rajesh was just mentioning about the localization of the semiconductor chips. What are your views about the massive shortage of the semiconductors? And how would you deal with the challenge of balancing your battery systems?
I don't think I have any points left to speak about. Rajesh has elucidated very clearly all the points. But I would say from the battery perspective, we have the protection circuits and the battery management systems, and also the communication protocols, semiconductor chips, where these chips are being used. As of now, we have not, as a company, felt an issue with the semiconductor shortage. And these are mostly attributed to the instrument clusters of the vehicles that are already there and are being mass produced, and also for the other normal vehicles. As for the solution of it, I would say that India needs to indigenize the production, as Mr. Rajesh clearly said. The PLI schemes are coming up, and there's one more possible solution is to go back to the older technology where we had enough production of those technologies, and try to update our software and use the older hardware. I don't know if that's possible or how will we do it, but that is that is one possible solution we can look into. The microelectronics part of it has become quite advanced. So yes, of course, the drive is always for the smallest chips and the highest processing chips. But as I said, that we can always go for the previous technology and use that while we expand our manufacturing capabilities.
You rightly mentioned about this. Along with that, what I would like to ask you is, there is a delegate, Mr. Abhimanyu. He would like to ask, please share your views on long-term advantages, EV or hydrogen technology. Most of the OEMs have started working on hydrogen since they think lithium battery have issues due to less mineral available.
Hydrogen is a relatively very high energy dense fuel as compared to a lithium ion battery, any kind of a battery for that matter. But saying that, there are several disadvantages of using a hydrogen vehicle or a hydrogen fuel cell. First and foremost of it is the low efficiency of the hydrogen cell as compared to the lithium ion cell. Lithium ion cells can use up to 75 to 80% of the total power generated to the total power delivered. That I'm talking about from the grid to the final performance of the vehicle. It can use up to 75-80% of what it takes. But if we look at the hydrogen fuel cell, from its production from its manufacturing to using it, we only see about a 30% efficiency. So that is one of the major drawbacks of using a hydrogen fuel cell. Other than that, there are other disadvantages as well. They are very flammable. They need to be controlled. They're not easily integratable. It's a very advanced technology, and it needs to be researched more before it is mass adopted. So going forward, yes, it can be a competitor for a battery system. But currently, I don't foresee a major adoption of these hydrogen fuel cells taking place. Refueling costs are very high, and it is very expensive to purchase and maintain. So the technology is not there yet, and also it is expensive. It is currently expensive to use and implement. And because the technology is not there, it is more dangerous to use. I would say that lithium batteries are here to stay for some more time, or at least other competing advanced cell chemistries are there to stay when we compare it to hydrogen fuel cells.
And we are also looking at a huge challenge of recycling.
We have the circular economy with the lithium batteries as well. We are developing the recycling facilities. And I'm sure that once we receive a critical mass adoption of the lithium-ion batteries in the market, they're going to come back and they're going to be recycled, and then we'll have a circular economy. So that is a positive point of it.
And when we talk about the future of automobile, it is definitely inevitable. Mr. Puneet, thank you so much for sharing your views. But I'm sure then Mr. Rajesh have something to add to that. Mr. Rajesh Kumar, what is your view on this?
Rightly captured by Puneet, the current adoption would be definitely not feasible in terms of business. But if we can categorize into one is the business aspect, one is the technology aspect, and one is the safety standards, how on the handling of these hydrogen fuel cells. If we can categorize into all these things, yes, business-wise, the feasibility would not be there, owing to the huge transportation cost, as well as your cost of producing hydrogen, which can be again filled into the tanks. So that could be a major hindrance at this point in time. But however, as we see, way back 10 years, solar also was in the similar stage where cost per unit was too high, and today it has come down to hardly 2 rupees per kilowatt, right? So in the same way, we see this transition happening. And on the second aspect, the usage of it and with a safe application, right? So especially in terms of transportation, right? It's cumbersome to transport, a lot of safety measures in place. And then, in terms of technology, I don't think this is a major hindrance today. In terms of technology, we can definitely adopt this one, but at what cost? Who's willing to pay for the cost of development of such technology? These are the kind of challenges that we actually, stare at today. But I'm sure, because today electric vehicle per se is not pure decarbonized way of looking at things, because we are just moving from your at the point of usage, probably you are reducing the carbon footprint, but elsewhere you are increasing the carbon footprint. But whereas with the case of hydrogen, you can see a complete clean that is decarbonization option. So a way forward to go on this hydrogen aspect with at least global players someone like Reliance, blue hydrogen, green hydrogen, Adani getting into a lot of these hydrogen power plants. So I'm sure very soon, probably 5 to 10 years down the line, it should take up a shape and probably kill electric vehicles, that is battery powered vehicles.
And it will definitely redefine the automobile landscape.
Absolutely. It will redefine the automobile landscape.
Mr. Arindam, there is a question from a delegate. He would like to know, can you give us a couple of cases where how AI or ML can be used for making electric vehicles smarter? Probably he must be looking at automobile manufacturing smarter.
I think it's not only an electric vehicle or a battery electric vehicle. It could make any kind of vehicle much smarter. Today, already there are vehicle technologies which use applications of AI and machine learning. If you talk about the advanced versions of ADAS or emergency braking systems, etc., they are already having applications like this. There are predictive maintenance kind of a scheduling and even tire maintenance schedulings. Today you have smart tires coming in which can tell you, because when you especially look at electric vehicles where the battery weight and the weight dynamics plays a very important role, I think to help if battery electric vehicle technology is here to stay, you will see a lot of new age technology coming in the tire deployment kind of an area, because all said and done, tires form also a very significant part of the cost of the vehicle, and maintenance of that is and how much kilometers do you get out of each tire actually decides the life cycle cost of the vehicle as well. So these are some of the areas. In terms of other areas like vehicles are becoming connected, so there is a cybersecurity element that is creeping in. Within cybersecurity applications, there are embedded AI, ML technologies that are helping us auto-detect, hacking attempts and correcting those, etc. So I think safety, maintenance, convenience for the user, the rider, these are broad areas where there could be numerous use cases. I don't think we all still know what all could be having such kind of
Yeah, good that you mentioned about life cycle of vehicle as well. But I would like to hear from you about your expertise. Definitely, you can comment on that. A vehicle scrappage policy has been recently launched to scrap old vehicles and reduce pollution. How comprehensive is this policy, you think? Especially from the value chain point of view.
Yeah. So I think it's a big, it's also a big first step that we've taken to become a more mature automotive industry. Any large automotive market that you see in the world has a very well-developed scrappage ecosystem that gets developed around the refurbished parts, scrappage, the right kind of a circular economy that Puneet was talking about, especially in the case of a context of a battery and such other electronic waste. We are talking about some time back about semiconductor chips. Now, if India has to leapfrog into that manufacturing, which Rajesh was also talking about, I think, we need to have a proper e-waste management and recovery of a lot of input material that can go back into further manufacturing again in the system. So I think it's a two-way process. Fresh manufacturing has to improve, which can also help the scrappage industry to kind of have a very stable, both parts have to work together because they're part of the same circle that we are talking about.
Thank you so much, Mr. Mr. Rajesh, what is your view? How it will leverage the auto sector in India?
Definitely, as Mr. Arindam said, the scrappage policy is a big boost to the automobile industry that we are looking at, right? So with constant the stagnation in terms of sales in the last couple of years would be we can see a lot of momentum with the new vehicles production, and with onset of EV industry, with the EV industry growing at a rapid pace, I think there's a very much right time for a vehicle scrappage policy to be in place and then lead way to the newer vehicles, and that won't be EVs. So that it's a kind of two aims. There is two aims that you can look at. One is reduce the old polluters, gas guzzlers on the Indian roads, and second thing is pave way for the electric vehicles to be on the road to decarbonize the environment. And the major thing is it will also create scrappage policy itself as an industry would create a lot of jobs in terms of handling these e-waste with the proper SOPs in place. So I think it's a win-win situation both for the government and the industry at large, automobile industry at large.
Mr. Punit, you were talking about the lithium-ion batteries. So do you think solid-state batteries are safer than batteries with this liquid electrolyte? And can they withstand the higher temperature to prevent fire, which is occurring? And it's a very harsh reality in the Indian automobile sector.
Well, yes. So I'll tell you the reason why lithium-ion batteries are currently so hazardous to use if they're not operated properly. It's because of using the liquid electrolyte. And liquid electrolyte, when it interacts with the anode, it forms SEI layers, and which becomes a point where a potential fire which becomes a point where if there's a external heat through that point, that can result it in thermal runaway of the cells. Solid state batteries using solid state electrolyte, and that would eliminate the possibilities of thermal runaway because of the external heat. That is definitely going to make the batteries more safer as compared to the batteries that we are currently using, which contains the liquid electrolyte. Other than that, the performance is also increases because the ions move faster in a solid state than a liquid state, and we have faster charging and even high temperature and low temperature charging that is possible, and their operations in those extreme temperatures. So yes, it will be a better product, but again, where we are at developing it commercially is the question whether they can be adopted in mass for our current usage.
Thank you, Mr. Punit. Definitely, we are improving and reforming about so that fire do not occur so occasionally. Mr. Rajesh, what are your views about this?
As Punit rightly mentioned, so in case of solid batteries, the risk of fire hazards is a lot lesser. Primarily for the reason that electrolyte being kind of more fluidic in nature, the transport, the movement is quite a bit, and any dendrites that we form within the cells that leads to short circuit, and then probably that leads to any sort of thermal runaways. And whereas in case of solid state batteries, the chances of thermal runaways are a lot lesser, and also the energy density would be higher, which actually can give rise to higher range vehicles. But again, as I said in the previous statement, where the hydrogen fuels with solid state batteries today, if you look at it, probably it will another 6 to 7 years down the line the commercialization would happen. So more or less the hydrogen fuel and solid state batteries would probably come at the same time. So that time probably people might have to choose which one is more user friendly in terms of pricing as well as in terms of usage. Solid state could be a quite competitor for hydrogen fuel cells going forward. And I feel hydrogen fuel cells would win the race, with the kind of advantages that it has.
Absolutely. Also, one of the delegates want to know, will any PLI benefit be there for scrappage industry to refurbish items? Any idea about that, Mr. Rajesh?
Okay, PLI benefit for scrappage industry to refurbish items. In fact, that is something which a lot of companies, especially the startups who are looking to get a hang of these electric vehicle entry, are looking forward for it. But as of now, there is no PLI for vehicle scrappages or to get into refurbishment mode. But government, I interact with a lot of government and industry bodies, and everyone is very keen for this refurbishment kind of model. But as of now, yes, it is not available. So because that's not a circular economy. If you do something like that, that's not a circular economy. The whole point is to have a circular economy where you pay with newer vehicles. The industry would grow, and that's how you get the economy get going.
Yeah, and hopefully we can look forward some very positive gestures from the regulatory authorities in the future.
Yes.
Yeah, Mr. Arindam, we are coming to the closure of this session. Can I request you to give a closing statement for this session today?
Thank you. I think it's been very engaging session. Thanks to my co-panelists and also the team from OEM Update to have selected first such a topic, and also tried to examine the topic from all the various different angles which are relevant in order to make India the third largest automotive market in the world. Those of us who are passionate about this industry in automobiles, those of who get fascinated by automobiles, I'm pretty sure we look forward to the time that India would rise to that coveted position. And all I can tell you is from my past experiences that and the various research, of course, not only the experience, is that the country's economy will also be much more strengthened should the automobile industry start performing even better, because it has great linkages for all kinds of materials, all kinds of application areas, and it encompasses a very, very large workforce, and which in turn actually impacts the economy of the entire country. And I think this whole new initiative around PLI for auto and auto components, which incidentally has got the largest share among the entire PLI scheme, and coupled with that, the very specific focus on the advanced chemistry cell batteries. I think these are very path-breaking initiatives by the government in terms of promoting the automotive industry. And we are at that cusp where I'm sure with so many, new startups coming up in this space and the whole space kind of opening up in a sense as compared to a very stable some 25, 30 OEMs. We have a large number of people who are trying to do various different things. I'm sure some will succeed, some will not succeed. But that whole exposure and that experience is what is very important impetus to make India the third largest automobile market. Thank you once again, OEM Update team, for bringing this together. And I'm sure the participants have also found this session very useful from their perspective. Should there be any questions, I am sure me and my other co-panelists will be happy to respond to that at a later date as well. Thank you.
Absolutely. And thank you so much, Mr. Arindam, for accepting our request. And it was our privilege to host each one of you. Each one of you are expert from the respective fields. Thank you so much for being here. And we are again looking forward to see you in coming sessions where OEM Update keeps on hosting industry talks every month.